Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we are going to discuss about the problem of viscous resistance of footstep bearing. So in our last lecture, we have already discussed about the theory part of this viscous resistance of footstep bearing, and we have derived the equation for torque required, and we have derived the equation for the power absorbed in that. So based on that, we will solve a problem with this. So here I've taken a question, find the torque required to rotate a vertical shaft. So in this first line itself, the question they asked, what is the torque required to rotate a vertical shaft? So our work is to identify the torque. So here what are the data are given? This is the question mark need to be find out. So data are given, diameter is 100 mm at 750 rpm. That means this vertical shaft is rotating. So shaft is situated suppose like this, and okay, and this vertical shaft of diameter here is given 100 millimeter, and this is rotating with the speed of 750 rpm. The lower end of the shaft rests on in a footstep bearing. So this is the concept also given, belongs to footstep bearing. So as we have seen, the footstep is, footstep bearing is located like in position like this, and between this shaft and this bearing we have the oil film. Okay, and this is also fixed part. So if you have seen the like the last lecture, there I have shown this is the picture of this footstep bearing. Yeah, now the end of this the end of the shaft and the surface bearing are both flat. Yeah, this is flat is there, and are separated by a oil film thickness of 0.5 mm. So the distance between from here to here, so that is nothing but T, 0.5 millimeter, and the viscosity of the oil is given. The oil which is used in between the shaft and the bearing is 1.5 poise. So we need to find out the torque. So as per the torque equation, we have derived the equation. So we know that torque equal to mu by 60T pi square n r to the power 4. This is the equation of torque actually. Okay, so what are the data is given here? So diameter of this is given. We can write diameter equal to 100 mm. So we can write 0.1 meter. Next, what are data is given? r.p.m. speed is given 750 r.p.m. Again, mu given here. Mu is given 1.5 poise. So that one we can convert into again meter. So that is 0. Just you divide by 10. So you can write 0.15 Newton second per meter square. Okay. Now any other data is given? Yeah, thickness, oil film thickness is given T. So T is given 0.5 millimeter. Again, it's just divided by 100,000. So we'll get 0.0005 meter. Okay. Now here diameter is given. So if you want to identify the radius, you can identify from here. That is nothing but 0.05 meter, because most of here formula, if you see, we have R values there. So all these values are given here. Just to put this value in this equation is very simple. Put the value of viscosity mu. So that is nothing but 0.15 into pi square. Into pi square is there. So just next, n value, speed is given 750 and r value is 0.05. So 0.05 to the power 4 divided by 60 into thickness T. T is already given here, that is 0.0005. So just to solve this one, you can get the value of torque. What is the torque required to rotate this vertical shaft? Okay, so let's find out. Okay, let's start one by one. So 0.015 into pi into pi into 750 into 0.05, 0.05, 0.05, 0.05. So this is the value what we got, divided by 60 equal to this one, again divided by 0.0005. Now see the value what you are going to get, 0.2313. This is the torque required, so I can write torque equal to 0.2313 Newton into meter. This is our final answer. Okay, what is the torque required to rotate the vertical shaft when it is positioned on the you can say footstep bearing? Okay, this is our answer. So sometimes the questions will be given different, like you need to find out the power required. So let's see another one problem related to this. Second question what I have taken, find the power required, okay, to rotate the circular disc. It is given circular disc given of a diameter 200 millimeter and 1000 rpm. The circular disc has a clearance of 0. See, the circular disc or this vertical shaft we can consider the similar way. Okay, so from the bottom flat plate and the clearance contents of the viscosity is 1.05 poise. So similar type question is there. Just I'll write the diameter is given 200 millimeter. So this one we can write 0.2 meter. 0.2 meter divided by 1000 u2. And again R also we can identify. If this is the case, we can write 0.1 meter. Next, RPM how much given? 1000 RPM given. So there is no problem in this. Next is given what? Thickness is given T. T is given 0.4 millimeter. So this one we can write in terms of meter. So that is nothing but 0.0004 meter. Again, mu is given 1.05 poise. This also need to be converted into meter. So what it will be the terms? 0.105 just divided by 10 Newton second per meter square we can get. Now what we need to calculate? We need to calculate the power required. In the previous question, if you see, this is here torque required given. So here the question is given to find out the power. So power formula is different. So power is what the formula we have taken here, just to multiply 2 pi nt, because if you see the formula is 2 pi nt by 60. So this was the formula. So power torque formula already have written. So here if you write this final terms, what we are going to get now, mu, and this is pi cube n square r to the power 4 60 into 30 into t. Okay, now if I write this formula, okay, then and see it is 2 pi nt by 60, correct? So t value already I have written here, mu by 60t pi square n r to the power 4. So again mu is there, pi square, and this is pi cube n square and r to the power 4 60 into 30t. So this is the actually formula. Anyway, now just put this all this value in this equation. So mu value 0.105 into pi to the power 4, pi to the power 3. So you can write pi to the power 3, and n value is given 1000. So 1000 to the power square, and r value is 0.1 to the power 4. So this is again we can write 60 into 30 into 0.0004. Okay, now we need to again we need to use this formula here just to make it 0, and I just can write 0 0.105 into 3 times 5. So pi, again 1000 2 times, multiply 1000 into, next is there what, 0.1 into 0.1, again 0.1, 0.1. How many? 4 times 0.1. Yeah, correct. Now, next what we'll do? Divided by, we'll do in brackets. This is 60, I hope. 60 into 30 into 0.0004, bracket close. Enter. This is 452.17. 452.17. This is watt. So this is the power required. This is the power required to rotate the circular disc of diameter, this one. So this is our final answer. Okay, so I hope you understand how to solve the problem also here. Like this is one kind of problem. So these are the problems can be given any kind of, like, in the semester exam, even in the competitive exam also, with a 2 marks or 3 mark question. Just we need to remember these formulas, this torque formula and the power required formula. So this is also, like, as we have discussed in the previous lecture, this is also linked. That means to find out the, just I'll tell the steps here. So this is the power formula. So here what is there? The torque is there. To find out the torque, we require the force. So what is the force? The shear force required. So again, to find out the shear force, again we need to go for shear stress. So this is force required, and again shear stress tau. Again, how to find out the shear stress? Now again we need to go for the formula of shear stress. So there again, area required, so area also can be calculated for that. So these are the steps, area, then shear stress, then we can go for the shear force, then we can calculate the torque required, then we can go for the power. So these are the steps out there. I hope you understand the problem and the concept of this. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.